Now we're going to talk about geometric series. A geometric series is the sum of the terms of a geometric sequence. And we know that any series, including a geometric series, can be either finite or infinite. We are going to start off by talking about a finite geometric series, okay, where you're adding up a countable number of terms. So in the box, we have a formula here that tells you how to sum the first n terms of a geometric sequence. If a geometric sequence has first term a1 and common ratio r, then the sum Sn of the first n terms, which is called the nth partial sum of the sequence, is given by the following formula. The nth partial sum, denoted Sn, is equal to a1 times 1 minus r raised to the nth power all over 1 minus r. And here, there's a stipulation that r, your common ratio, cannot be 1. Okay, if you're interested in where this formula comes from, I will provide a justification in the last video on the last page of this note packet. All right, so let's do some practice using this formula. Okay, in example 4, we have two geometric series that we are going to evaluate. Okay, first thing to notice about both of these is that they are finite geometric series. Okay, so this first one, J is our index of summation. It starts at 1, it goes up to 5. We're adding up 5 terms. This will converge. Every finite series converges. Okay, the second one, the index of summation is K. It starts at 3, it goes to 9. Again, we're adding a countable number of terms. We should be able to get a number as the answer. We will. Okay, all right, so let's start with the series in example A. Okay, we are summing the expression 243 times 2/3 raised to the j power, and we're doing this from j equals 1 to j equals 5. All right, so you've got the first, the second, the third, the fourth, and the fifth term. So there's only 5 terms. You could, just plug in you could compute each term separately and then add them all up. Okay, that's plausible. But again, I want to show you how to use the formula in case you're having to sum up 100 terms and you don't want to, compute each term individually and then add them up. That's just too tedious. Okay, so let's practice using the formula here. First, notice that this is geometric. Okay, if you get this on an exam or something, how do you know this is geometric? Okay, it doesn't tell you in the directions, okay, but from the discussions we've already had about geometric sequences, you should notice that the j, the index of summation, it's in the exponent. Okay, when you look at this, it is fitting the bill of a number times the r value. This should be the common ratio raised to the nth power. Okay, so we talked about this. This looks like it is a geometric sequence because it is fitting the format, the algebraic format of a geometric sequence that we're adding up. Okay, all right, so we know that whatever is being raised to the power here, that is going to be our r value. Okay, so r is going to be 2/3 here. Okay, to use this formula, we need not only r, but we also need the first term of the geometric sequence. Don't fall into a trap here and automatically assume that 243 is the first term. Go ahead and take the extra step and calculate the first term just to be sure. It really depends on whether your exponent is j or j minus 1 or something else. Just be safe and calculate the first term. Okay, so if j is equal to 1, let's get the first term here. So a1 is going to be 243 times 2/3 raised to the first power. Okay, I'm going to go to the calculator and plug this in. This is going to be 243 times 2/3 raised to the first power. Okay, so your first term is actually 162. Okay, and that is again because your exponent is j and not j minus 1. Okay, just calculate the first term. Okay, all right, so now we can apply our formula. Okay, for the nth partial sum. Okay, let's write down the generic formula. It is a1 times 1 minus r to the nth power all over 1 minus r. Okay, we need to apply that here. Okay, we are looking for S5. We want the fifth partial sum because we're adding up, starting using this formula. Keep in mind, you have to start at 1. Okay, using this formula assumes that you're starting your addition with the first term. So we're adding from the first term to the fifth term. So we are computing the fifth partial sum, which tells us that n has to be 5 here. Okay, so if we plug that in, we're going to get that S5 is equal to A1 times 1 minus r to the fifth power all over 1 minus r. Okay, if we plug in all the information here, we know that A1 is 162. We're going to multiply that by 1 minus the r value, which is 2/3 to the fifth power. Okay, the power is on the r value. Okay, the denominator is going to be 1 minus the r value. Okay, all right, so we're just going to plug this into the calculator. You need to be very cognizant of order of operations depending on how old your calculator is. I'm going to start by putting the numerator in. Okay, so I'm going to do 162, open the parentheses, 1 minus the r quantity, which is 2/3. I'm putting it in parentheses because my calculator is older. I'm going to raise that quantity to the fifth power, and then I'm going to close the parentheses. Okay, this is the numerator. Okay, I'm going to divide it by the denominator. I need to put the entire denominator in parentheses here. So it's going to be 1 minus 2/3. Okay, so here we go. The sum, the partial sum, the fifth partial sum here is 422. Okay, so if we did do this individually, we computed each term individually and then added them all up, okay, we should get 422. Okay, but again, it's good to know how to apply the formula, okay, in case you're adding a whole bunch of terms. Okay, all right, so this means, again, remember what this means. If you add up A1, A2, A3, A4, and A5, you'll get a sum of 422. Okay, this series converges to 422. Okay, all right, let's move on to the second series here. Okay, this one's tricky. We saw something like this with arithmetic. Our index of summation does not start at 1. It starts at 3. So here you're adding the third term, the fourth term, the fifth term, the sixth term, the seventh term, the eighth term, and the ninth term. Okay, you can use the formula above, okay, which is only for finite geometric sequences here. But in using that formula, remember the index of summation has to start at 1. So you have to get tricky. Okay, we did this with arithmetic, so we're going to do the same kind of thing here. First, let's recognize that this is indeed a geometric series. Let's look at the expression that we're adding up. So you've got an exponent here. Okay, your index of summation is in the power. Okay, that tells you, you know, that this is geometric. This expression is fitting the bill of some number times r to the nth, or k here, power. Okay, so we know this is geometric. Okay, we're really multiplying by 1 out front, so the a value here is 1. The common ratio here is going to be -3. If we did write out the terms of the series here, we would have alternating signs. Okay. All right, so let's try to apply the formula here. Okay, how can we do this because our index starts at 3? Okay, well, remember what we did with the arithmetic one that we saw here. Okay, we started by adding up the expressions. We started by having an index of 1. Let's say that. Okay, so let's add everything up from 1 to 9. Okay, and then you have to take out the terms you don't want. So we have to take out the first term and the second term. So yes, here it's only 2 terms that you would take out. So you could take them out separately, but again, I'm going to show you how to do this in bulk in case you have, you know, a large number of terms. All right, so we're going to add everything up from 1 to 9, and then we're going to take out the first and second terms. So we're going to take out the sum from 1 to 2. Okay, this will remove the first and second terms. Okay. All right, so these are the two sums that we need to compute. Okay, they are both geometric series that are starting at k equals 1. We can apply the formula. I will do the first summation in red, and I will do the second in green, so everything is color coded and you can follow what I'm doing. Okay. All right, so again, for both of these, we will be applying the formula that the nth partial sum of our geometric sequence or series is going to be a1 times 1 minus r to the nth power all over 1 minus r. Okay, here we need to realize that our r value is -3. Okay, r is -3. Let's go ahead and figure out a1 because we're going to need it. Okay, a1 is the first term in the sequence. Okay, so we would go here and we're going to let k equal 1. So let me write that. So if k equals 1, that's what we plug in to get the first term, a1. This is going to be -3 to the first power. Okay, so this just means it is -3. Okay. All right, so now that we have that information, we can plug in. Okay, let's start with the first series here. Okay, so I want the first series is recognizing or is calculating the 9th partial sum. Okay, we're starting at 1 and we're going up to 9, so we're adding the first 9 terms of the series. So here we go. Okay, we're going to plug in our k value here is 9. We're getting S9. We're going to go to our formula. Okay, over here, the generic formula, everywhere you see an N, you're going to plug in 9. Okay, so to compute S9, you're going to do A1 times 1 minus R to the 9th power divided by 1 minus R. Okay, if we plug into this, this is going to tell us that we're going to have A1, which is -3, times 1 minus the R value. The R value is -3. Be careful here. We're raising that to the nth power, which is 9. Okay, so that's how you plug into the numerator. The denominator is going to be 1 minus the R value. Again, the R value is negative. Be careful here. Okay, I'm going to go to my calculator and pop this in. Okay, again, be very aware of your order of operations here. Okay, so I'm going to plug in the numerator first. I'm going to get -3 times 1 minus -3 raised to the 9th power. Okay, so here's the numerator. Okay, I'm going to go ahead and divide that by the denominator. The denominator is 1 minus a -3, that's 4. Okay, or you could do 1 minus a -3 and let the calculator do it. Okay, so this, the 9th partial sum, if you add the first 9 terms of the series or the sequence, you will get -14,763. Okay, so -14,763. Okay, should you be surprised about a negative power? Okay, or sorry, a negative answer? The answer is no, because remember, you have a negative R value. The signs are alternating between negative and positive. Okay, so it's okay to have a negative sum here. Okay, moving on to the other series here. Okay, the one in green. Okay, so we just need to add up the first term and the second term. Okay, it might be quicker to just do that manually. Okay, but we'll practice with the formula here. Okay, so for the second formula, since we're starting with the first term and adding all the way to the second term, our k value is 2 here, where we're going to be adding the first 2 terms of the series. Okay, so we're going to be computing S2. Okay, so if we apply our generic formula over here in blue, this is going to be A1 times 1 minus R to the 2nd power. Everywhere you see an N, you want to replace it with 2. Okay, that's your k value or your N value. We're going to divide by 1 minus R. Okay, plug everything in. The first term is -3. We're raising, or sorry, first term is -3. We're multiplying that by 1 minus the R value, which is -3, raised to the 2nd power. Okay, the denominator will be, again, 1 minus a -3. Okay, so let's calculate this. This is going to be -3 times 1 minus -3 squared is +9. The denominator will be 4. Okay, so this is going to be -3 times -8 over 4. We don't even need our calculator here. All right, so this is going to be 24 over 4, which is just 6. Okay, that's a very small number. It makes sense because we're just adding the first two terms. Okay. All right, so we've got what our red series converges to. Our red series converges to negative 14,763. The green series converges to positive 6, and we need to subtract the two. Okay, so we're going to go ahead and do that. I'll put a minus sign in the middle. Okay, and if we do that, negative 14,763 minus 6, okay, the overall series converges to this number, okay, negative 14,769, okay. So this means if you went to the original series, okay, and you wrote out the third term through the ninth term and you added those guys up, okay, you're going to get negative 14,769.